Okay, so we're looking at the second year Stats and Mechanics textbook, and we're on exercise 8D, which is from the mechanics section and involves differentiating vectors. So an exam question, just single part to it worth 5 marks. I'm given the position vector and I'm asked about the acceleration. So the only sort of slightly tricky thing about this question is they haven't broken it down into stages for us. So I need to twig that. If I differentiate position vector, I'm going to get velocity. So we're differentiating this vector here. So 2t squared is going to differentiate to 4t, and minus 3t will differentiate to minus 3. And 5t will differentiate to 5, and t squared will differentiate to 2t. Okay, so there was no reference to velocity, but I need to join the dots and realise, well, I can differentiate position to get velocity, and then I can differentiate velocity to get acceleration, or it's the second differential. Okay, so we don't need to specifically refer to velocity. Okay, so now I'm differentiating this. I'm differentiating the velocity vector. So 4t minus 3 is just going to differentiate to 4. 5 plus 2t is just going to differentiate to 2. So there's my acceleration vector. So show it's constant. Well, we have done that, but let's actually really be clear that we know why. So a is constant because it is not dependent upon time. So because it is not dependent on time. Okay. Find its magnitude. So the magnitude of velocity, so there isn't a special word for that, it is just the magnitude of velocity. So I'm looking here and I'm just using Pythagoras on 4 and 2. So that's just going to be root 20, which to 3 significant figures is 4.47 meters per second squared. Okay, let's just check those answers. So 4 plus 2, yeah, and then they've left theirs as a simplified surd. Okay, 3 significant figures is also fine.